Hi, good evening. Today, or tonight, I should say, we're going to review some of the material that we did last week in our class, and if there's time, maybe give you a little preview of something that's coming up in the following week, coming up this week. So this is an Introduction to Java course, and in this last week, we were learning how to create variables, create objects from classes, and manipulate them using methods. And we were using the classes of JFrame and Date in order to show you these examples. And so I'm going to kind of walk you through the exercise sheets that we did in class on, I think it was on Wednesday. And then hopefully you can, and this will be review for some of you, because actually if you did these sheets in class, you have most of the answers. So, and also I'll give you maybe a couple of hints about doing the assignment, the actual assignment pages. If you log on and you are in the chat, you can ask questions and I can try to answer them. So let's get started here. The first question was to declare a variable called volume and assign it the value of 8. So you just go over to the BlueJ CodePad. And there's no information here about what type the variable is, but you can probably kind of assume that it should be an integer because it just says the value is 8. So we'll go int volume equals 8, semicolon, and that now creates a variable called volume and assigns it the value of 8. And then we can find out what its current value is by just simply typing in volume, no semicolon, press enter, and it tells us the value is 8. The next question was to change the value of volume to 11. And in this case, we just assign it a new value like this, volume equals 11. And then we can verify that it has the new value by typing in the name of the variable, pressing enter, and see that it's 11. So here's a couple of things just to digress a bit. What happens if I make another variable called volume and try to assign it the value 20? Well, that's not going to work because it says that I've already got a variable called volume defined within my program. So you can't define or declare the same variable twice. And Java knows that you're trying to declare a variable if you write it with the name of the type out in front of it, like I've got right here. So seeing the word int followed by the name of a variable tells Java I want to create a new variable called volume, but it's not allowing me to do that. I can't have two variables. And for now, I'm going to say within the same program, but in the future, I'm going to change that to say it's called within the same scope. And we'll find out in a few weeks probably what scope means. But it doesn't mean you can't have two variables of the same name in your entire program. There just can't be two variables of the same name kind of next to each other. Okay, another thing that comes up is what happens if maybe I declare a variable called area, but I don't give it a value. Okay, there's a little note that comes up. What it's trying to say here is that variables in the CodePad work the same way they do in a regular program. You don't have to worry about that message really. But let's find out what the value of area is if we haven't given it a value. And we find out that its value is 0. So if you declare a variable but you don't give it a value, it will implicitly assign it a value of 0. So behind the scenes, it'll just say, oh, you probably want to give it a value of 0. Now, it's a good practice to give your variables a value anyway, because you're explicitly telling the program, here's what the value should be, rather than kind of relying on the Java to do the work for you. And in fact, the Java compiler, the thing that interprets or translates your programs into what the computer understands, will sometimes give you a warning to say, hey, it looks like you declared a variable here, but you didn't give it a value. So that might be something you want to look at in your program a little more closely. So just be aware that integer variables, like I've got here, get a value of 0 if you don't explicitly assign them, but it's a good practice to do so. All right, let's move on to number 3, which says, here's a variable declaration. So I'll go ahead and type that in, int temperature equals 60. So that should give it the value of 60, and we can verify that by typing in the name of the variable and see that it comes out to be 60. Now it says, write an assignment statement that would add 10 to the temperature variable and store the result back into the same variable so that the new value should be 70. So it's not good enough to just say temperature equals 70, because that's not adding 10 to what's already there. You're doing it internally in your head. You want the computer to do that. Nor can you just say temperature plus 10, because although that displays the number 70, it hasn't stored it back in the variable. So if I type in temperature again, it just says 60. So temperature plus 10 looks at the value inside the box, sees that there's a 60 there, adds 10 to it, displays 70 on the screen, but doesn't change what's in the box. To change what's in the box, you have to use the assignment, temperature equals, and then on the right-hand side, you want to put what the new temperature should be. So I'm going to say temperature equals temperature plus 10. So this is going to look up the value of temperature, add 10 to it, and then the value that gets calculated, which would be 70, then gets stored back into the variable. So the assignment operator, the equal sign, kind of works in reverse. It evaluates the right-hand side first, coming up with the value, and then evaluates the left-hand side to figure out where it should store the result. So this is the way to add 10 to a variable and store it back into the same variable. So we can now look to see what's in there and see that it's 70. So now it has actually changed the value. Okay, next part. Write an assignment statement to divide the value of temperature by 2. The new value stored should now be 35. So this is similar to what we just did a couple lines above. Temperature equals temperature divided by 2. And then we can see what value is in there, and it's 35. So a little digression. What would happen if we did the same thing again? So if we did divide by 2, what do you think is going to get stored in there? So one possibility is that something like 17.5 gets stored in there. Another possibility would be just 17. A third possibility might be 18. Maybe it rounds it up. So let's find out. And we can see what's there. And it's 17. And this is because since temperature is an int variable and 2 is an int, it does integer division, which means it lops off any remainder or any decimal place. So it's always going to round down if it's positive. No, it's not really round down. That's not the right term. It's just going to truncate off the decimal portion. Okay. 4. Prepare Java to use the JFrame class by importing javax.swing.jframe. So the command to use there is import javax.swing.jframe, semicolon. Now, let me pause for a moment and say that you don't have to type in that import statement. You can very well do your entire this entire project without doing that import. It just means that whenever you do something like on the next thing, create a JFrame object, you can't just type in JFrame by itself. You have to type in the whole name, javax.swing.jframe. So using the import doesn't really prepare Java to use the JFrame. It just makes it so that you don't have to type in so much stuff. So you can just type in JFrame and it understands that you're actually talking about javax.swing.jframe. A couple of things that come up, people ask me like, well, does this make my program faster or slower if I use the import? And the answer is neither. It works exactly the same speed with or without the import. It's just a matter of how much typing you want to do when you're writing your program. Another question that comes up is, what's the deal with this whole JavaX swing JFrame? And I guess the short answer is Java, the programming language, comes with, I think hundreds is an understatement, probably thousands of classes that give it all the functionality that you come to expect, like things like Windows and networking, audio, video, being able to work with 3D models, 2D models, importing text files, just we're accessing databases, just thousands of things it needs to do. And all of these things have names. And the problem with having thousands of things you need to name is after a while, you start kind of running out of unique names. So If you call something a window, well, there can only be one thing named window. If you want to have different kinds of windows, you might have to start putting prefixes on them, like big window, small window, red window, blue window, and so forth. And so one of the ways to kind of get around this problem is to put all these different things, all these different classes into different boxes. They're called packages. And so you can have one package consisting of a bunch of classes that give it a certain functionality, and another package that has classes that give it yet a different functionality. And the nice thing about putting in packages is then you can have the same names for classes in different packages. So the JFrame class is inside of a package called swing, which is inside of a package called JavaX. That's the short story there. There's another question is like, what's the deal with the J on the JFrame? And J obviously stands for Java. And the answer there is there used to be a class just called frame. And that's actually part in a package called SWT or AWT, the abstract window toolkit. And that's inside of a package called Java, not JavaX. And I think frame ended up being a very generic term. And the problem with the old style of frames is that it didn't look like Windows, it didn't look like Mac, it didn't look like Linux. It had its own look and feel, and users were kind of unnerved maybe, or kind of disappointed that Java applications didn't look like their native operating system. So along came a new package called JavaX and Swing, and then there's all these things inside there called J buttons and JFrames. And the idea is that when I create a JFrame, it looks just like a Mac window or a Windows window that you're used to, rather than just this weird kind of Java look. Anyway, so there's a whole bunch of history there. Java is an old language. It's now practically almost a little over 20 years old. So there's plenty of history behind it and why things are named the way they are. Anyway, let's move along. And it says create a JFrame object and assign it to a variable called mywin. So it's not much different than creating variables like temperature over here. We still need to give it a type. In this case, the type is going to be JFrame. We need to give it a name, which is going to be mywin, then the equal sign. And then instead of giving it like the number 60, we're going to say create a new object from this class, make a new thing called a JFrame. So the statement there is JFrame mywin equals new JFrame, parentheses, parentheses, semicolon. Okay, so creating an object from a class is not a whole lot different from creating an integer. As far as the way it looks, this is the type here. Instead of int, it's JFrame. This is the name of the variable. So instead of temperature, it's mywin. There's still an equal sign there. And then this is the part that's really kind of different. It's the word new, and then the name of the thing or the type of the thing that you want to create, which in this case is a JFrame, two sets of parentheses and a semicolon. And at this point, I have a variable called mywin that represents a window on the screen. And you can't see it. It's there. It's, see if I can get up there in the corner, but it's invisible right now. So the next thing is make the window visible. And you do that by invoking the setVisible method and pass it the value true, which is a Boolean value. So you say mywin.setVisibleTrue, and then there's the window. It's up there in the corner. It's pretty small, but that's it up there. There's not much to it. That's about as small as you can get. But the next thing is give the window the title mywindow, and then set the size to be 200 by 300. So let's go ahead and give it the title. So that's mywin.setTitle. And then inside the parentheses, you're going to put in a string. In this case, I'm going to use a string literal, like, what was it say? Oh, my window, semicolon. And you can hardly see it, but there's the title. There's the M, the beginning of the M right there. So we're going to have to make this window bigger in order to see the whole thing. So the next thing was set the size of the window to be 200 by 300. So mywin.setSize 200, 300. So the setSize method needs two values, the width and the height, to tell it how to set the size of the window. And I'm going to press enter, and we should see it change its size. So you can see that now we can see the whole title. it's grayed out because this window is not the frontmost window. If I click on it, it becomes the frontmost window. Now, let's do some other things before we move on to the next one. Let's go mywin.setTitle, also my window. And now it's going to change what you see in the title. So you can kind of imagine that behind the scenes, inside of the class that represents a window, are these variables that hold the properties of the window, like its size, its location on the screen, its title, whether or not it's visible, whether or not it can be resized. There's actually probably hundreds of properties of a window, and these methods are manipulating those properties. So as soon as I make it visible, it shows up. As soon as I can do my win.set visible false, and the window will go away. It's still there, because if I make it true, it reappears. Now, this is a window just like any other window. There's nothing inside of it, but the outer frame of it is just like any other window. I can move it around. I can resize it like any other window. So I can make it long and skinny like that. And then if I do the set size method again, it just pops back to the size that I told it to go to. So when I do all these manipulations with my mouse, behind the scenes, this stuff is happening. So what you do with a mouse is making things like set visible, set title, set size. Those are all happening behind the scenes. What if I close the window? I use the close button here. Do you think it's still there? Well, let's just make it visible again. And there it is. So really, the close button on a window doesn't make the window go away, and it doesn't like quit the window. It just makes it invisible. And then you can make it visible again by just telling it to become, by using set visible. Okay, so this is true pretty much of any other window on your operating system. When you click that close button, it doesn't necessarily make the window vanish completely. It just simply makes it invisible. All right. Let's do some more things before we move on to the next question. The window has disappeared, so there it is. It can get easy to lose this window. All right. So I want to find out, now that I've resized it here, I want to find out what its current size is. And the methods to do that are called get height and get width. So there's no get size method. You have to get the dimensions individually. So it says the current height is 247, which should be the dimensions from the top left-hand corner of the window to the bottom, actually from the top edge to the bottom edge. And I can do get width, and it tells me it's 862 pixels all the way across. If I resize it a little bit and then do get height and get width again, you can see it now. These methods are returning the new values. So again, when I resize it, behind the scenes it's just doing a set size. We can find out what its current location on the screen is with mywin.getX and mywin.getY. So it says it is at 156.30, so that's 156 pixels from the very top left corner of the screen, and then 30 pixels down. And where it's measuring from is this very top left-hand corner of the window, right here where the curve is. Okay, so in Java, the coordinate system is upside down from what you think it might be. The top left-hand corner is where 0, 0 is, and then the Y direction goes down. The X still works from left to right like you'd expect, but the Y direction goes down. All right. Create a second window and assign it to the variable mywin2. All right, so we go JFrame mywin2 equals new JFrame. So now I have two windows. One's here. The other one is, well, it's up in the corner. It's invisible and it's really small, but it's there. Now it says show the window and set the title. MyWin.setVisible. True. Oh, sorry, that should be MyWin2. There we go. And then MyWin2.setTitle to be second window. Okay, you can barely see the S on there. And then it says change the size of MyWin2 so it's exactly the same size as MyWin. So we want to make the dimensions of the new window match the dimensions of the old window. And I had a comment here that says, can I create a window that is not a rectangle? You know, in Java, you can. It's, I would say, not easy to do that. But basically, you can take the JFrame and replace the default look and feel of it with something else. And I'll make it short and say it's quite involved how to do that. But yes, you can certainly do that. And the other answer is I don't know how to do it myself. I'd have to look it up. So, but I know it can be done because I've seen it done. Okay, so we're going to make the second window be the same size as the first window. So there's two ways to do it. The lazy way, lazy being lazy for me, the programmer, and then the way you might think of doing this. And so the way you might think of doing this is let's ask the first window how big it is. So we'll go MyWin.getWidth, and it says it's 144 wide, and MyWin.getHeight, and it says it's 448 tall. So I could go MyWin2.setSize, and then pass in those two numbers, like that. And now the second window is exactly the same size as the first window. They're not lined up across the top, but they are the same dimensions. Okay, this is not the lazy way to do it because I had to go and ask the first window and then get the number back, 144, and then ask the first window, yeah, its width, get the number back, ask the first window for its height, get the number back, remember them in my head, and then plug them into set size. So the lazy way to do it is all in one fell swoop without ever seeing any of the numbers. So let's take this window and make it small again, like this. And now, instead of plugging in those numbers, I'll just put in the thing that came up with this number, the 144, which is this here. I'll go MyWin.getWidth. And I added an extra space there just to make it a little easier to read. Java doesn't care if you add an extra space there. Okay, so this is the expression that came up with that 144. So instead of seeing the 144, it's just going to evaluate to that value, 144, and then plug in that value when it calls set size. And then we'll do get height. Close off the parentheses. So this one matches the one way over here. And then the semicolon. Let me make this window a little bit bigger so you can see the whole thing. Okay, and then when I press enter, you're going to watch that window change its size. There it goes. So now it's the same size. And notice that I never saw the numbers. In fact, let's take this first window and let's make it like this. Let's take the second window and move it down here so we can see it. Okay, and I'm going to repeat that same thing. In case you don't know, to repeat the same command in BlueJ, you just hit the up arrow key, and it brings up the previous thing that you typed in. You can keep hitting up arrow, and it goes back through the previous things. Down arrow goes back down the list. So I'm just hitting the up arrow here, up arrow key, and then I press enter. And now the second window is the same size as the first window, and actually I have no idea really what the actual dimensions of the first window is. All I know is that the second window is the same dimensions as the first window. Okay, so this is the lazy way of doing it because I don't have to remember anything about the size of the window. I just say, ask the first window how big it is, and then plug those numbers into set size, and it'll happen. All right. So let's do some other stuff before we move on to the next page. Let me put this out of the way so we can see the windows, and let me get this out of the way. All right, so here's our two windows, and I'm going to resize this one to be about like that. And so what I want to do is I want to position this second window. Let me make it a little bit bigger. I want to position this second window so that it ends up right next to the first window, lined up across the top and, butting right up against it. And again, I want to do this without referring to any numbers. So maybe the way to do this is so you can see the numbers first, see how it all works out, and then we'll try it without the numbers. So I want to get the top left-hand corner of the second window right next to the top right-hand corner of the first window. So to do that, I need to know what's the coordinate of the top left corner of the first window, add that to the width of that window, and that'll give me where the top left-hand corner of the second window should be. Do you see that? So I need to know this distance right here where I'm moving the mouse. And then I'm going to add to that the distance across the width of this window. And that brings me to the top right-hand corner of the first window. And then as far as the distance down, that's going to be the same as the first window. So I don't need to add anything. I can just use the y coordinate of the first window to figure out where the second window should go. Okay, so let's see what those numbers are. So I go mywin.getX. That says 156. So that means the distance from the left edge of the screen to the left edge of the first window is 156. And then mywin.getWidth is 307. So that's the distance from the left edge of the first window to the right edge of the first window. And if I add those together, I can just do it right here on the code pad, I get 463. That's where the top left corner of the second window should go. It should go 463 over from the left-hand side. And then if I go mywin.getY, it says it's 30. So that's the distance down from the top edge of the screen. Okay, so if I go mywin2.setLocation, and I plug in 463 and 30, which are the two calculated values, 463 and 30, that should pop the second window up there. So let's see if it happens. Boom, there it goes. So you can see, although the windows are different sizes, I haven't changed the size of the windows. The second window is precisely where I want it to be, right next to the first window. So let's move it again. And if I do the same command, you see it goes right over there. Okay. So now let's do the same thing, but let's not put in those numbers that we had to calculate and then remember in our head. Let's go mywin2.setLocation, and then we'll put in the expressions that calculated that number, 463. And that was getX plus getWidth. All right, so there's the calculation to find out how far over that second window should go. It's the first window's X coordinate plus the first window's width. And then for the Y distance, the distance down from the top, we'll go mywin.getY. So that's the second argument to set location. Close off the parentheses for set location, a semicolon, and then there it goes. And you can do that no matter where this first window is. So if I put it over here, and then do this, the second window goes right next to it. Okay, so again, I didn't have to know anything about where the first window actually is. It'll just position the second window over to its right, even if that means going off the screen. So one thing to notice here is that when I drag the first window, the second window doesn't go along with it. So that's because I need to do this statement again. It's not like when I do this statement, it's true all the time. It's true kind of in perpetuity. So this is an important thing to remember, that you need to move. If you move one thing, it's up to you, the programmer, to move the other thing along with it. So if you want these two to move together, you need to somehow, and it's beyond the scope of this this course right now, of how to get the second window to move along with the first window. Right now, all we can do is kind of just move it into a new location and then run another statement and have the second window move. All right. So if you want to position a window relative to where another window is, you're going to have to do some calculations to figure out, where is that first window? How wide is it? How tall is it? And then position the second window next to it. On the assignment that you're doing, you're not going to be positioning it next to, you're going to be positioning it underneath. And there's also going to be a little bit of a gap. And there's another challenge problem where you have to get them kind of like that with the corners touching. So again, you're going to be using same techniques, but just doing different calculations. All right, let's move on to the next part, in which it says, create a date variable named the date and assign a new date object to it. All right, so again, we don't have to do an import, but it saves some typing. If I go import java.util.date, now I can go date, the date. So this is the type of the variable, and the name of the variable equals new date, parentheses, parentheses, semicolon. Notice that the format of that statement looks almost identical to making a JFrame, except that instead of using JFrame and MyWin, we're using date and the date. Otherwise, it's the same thing. And I really want to emphasize that. It's the same thing, the same concept, just with different words. Now it says, before we do the next one, construct a string containing only the time in the usual hour-minute format. Before we do that, let's use the date.toString. And I want to see the value. And it comes up and it says, Sunday, February 21st, 20:02:30 p.m. Pacific Standard Time, 2016, which is the current time. And if I do this again, so notice that the numbers aren't changing, right? So why is that? And the answer is, when I create this variable and I give it its value doesn't update constantly with the time. Its value is stuck at the moment that that variable was created. That was the date and the time at the very moment when I press enter to create that variable. There probably is a method inside of the date object to get it to update its current time, but it's not important for this assignment. But it is important to realize that the value of a variable doesn't just spontaneously change. You need to tell it to change and what to change it to, or if it's automatic like the date, tell it, go ahead and update yourself to the current time. Okay, so that's important to realize that variables don't just spontaneously change values. Okay, now it says construct a string containing only the time in the usual hour-minute format. And to do this, you need to know the methods to retrieve the various fields out of the date class. And there are things like get hours, which returns 20. That's the 20 that's right there. The date.get minutes, which is 2, which is that number right there. And the string prefixes the numbers with a 0 like it should be, but the actual number that's stored in there is just the number 2. The date dot get year. I'll explain in a little while here why that returns 116. Get date, which returns actually the day of the month, the 21st. And then there's get month and get seconds and all those other things like that. But anyway, I want to construct a string containing only the time in the usual hour-minute format. So let's go the date dot get hours, and then append that to a colon inside of quotes. So I just want to take a literal string containing just a colon, and let's add it to the date dot get minutes, and that's going to put the two of them together. Now, it contains the 20, which represents 8 p.m., and here's the 2, which represents the 2 minutes past 8 o'clock. It doesn't have that leading 0. It would be up to us to put that in by ourselves, and we'd have to do some kind of check to see if the number of minutes is less than 10, and if it is, put a 0 there, and if it's not, don't put a 0. We're not going to get into that just right now. So we'll say it's okay for now if the leading zeros aren't there. The idea is just to get those two pieces stuck together. Now, let's do something else that's not on this page here. Let's get the date. So I want to see February 21st, 2016 since I'm in the United States, we're going to go with the United States format, which is month slash day of month slash year. And maybe in a moment here, we'll do it like European style, which is, I think, maybe with dashes or slashes, but in a different order. But let's go month slash day slash year. So we're going to go the date dot get month, and then append that to a slash, and then the date dot get date, which returns the day of the month, and then concatenate or append that to another slash, and then the date dot get year. And this is going to make one string that contains those three values separated with slashes. And we get 121, 116. So the 21 is correct. Today is the 21st, but it's not January, and it's certainly not the year 116. So let me explain a little bit about where these numbers come from. First, the number 1 here. The date is actually stored so that the very first month of the year, which is January, is month 0. December would be month 11. So February is actually month 1. And the reason for that is the values stored inside of the date are just numbers, like the month and the day and the year and the hours, minutes, seconds. It doesn't store the names of the months. And the reason for that is, one, it's sort of redundant information. Why would you store the number 1 and the word January? I mean, it's kind of convenient for us programmers, but it's really redundant. You only want to store something once. And the other reason is English uses the word January, but other languages use different words for the month of January. So you wouldn't want to store all those different names for all the different months in the date class. You'd want some way to translate it from a number into the appropriate word. And so those words are not stored anywhere inside the class at all. It's up to you, the programmer, to translate them accordingly. And so the way you do that is you store the names of the months in something called an array, which is kind of like a whole sequence of boxes. And the boxes just start numbering at 0. So you can imagine you have this array, and you put January in the 0th box, February in the 1st box, March in the number 2 box, and so forth, all the way down to number 11, which would be December. And then it's easy to go and look up the name of the month from the number of the month, because the number of the month corresponds exactly to the box number that it's in. So that's why the numbers start at 0. So the way to get it to display 2 there instead of 21 is you're going to need to add 1 to the month. and I put it inside of parentheses to get it to do that addition first before it tacks on the slash. Otherwise, there's a risk it might actually go 1 and then 1 slash. It's basically making 11 because it just tacks the 1 onto the end. Okay, let's try it out. Okay, so that's right. We added 1 to the month to get the proper number 2, and now we're left with 116 as the year. And why is that? So this actually requires a little bit longer explanation. This is actually left over from the Y2K problem. Remember I said Java is about 20 years old? So it was created back in the 1990s when Y2K was kind of on people's minds, but not really. And so the people who created Java, and actually the people who created practically every programming language at the time, said that when you return the year, you're just going to return a 2-digit year, like 97 or 86. And then it's going to be up to the programmer to tack on the 19 in front to display the year correctly. So if the get year method returned 86, what the programmer would do is go 19 plus the date dot get year, and it would very nicely display 1986. Okay, so along comes the year 2000, and now you've got a problem. You've designed the get year method to return a 2-digit year, and because potentially millions of programs have been written relying on the fact that it returns 2-digit years, means you can't just change course and say, okay, from this point forward, get year is going to return a 4-digit year. Because what would happen with old programs is they would display, let's say the year was 2005, they would display 192005. You can see because they're just explicitly putting the 19 in front of the year, right? And so you don't want to what's called break all these existing programs to fix this problem. So the people who created Java, and not just Java, like I said, there's a lot of other programming languages, said, well, how are we going to solve this problem? We don't want to break old programs by having it suddenly return a 4-digit year, but we still want to make it kind of work as the new millennium starts. And so what they did was they were, I guess, a little crafty about it and said, okay, it's not really a 2-digit year. What it is the number of years since 1900. Which, if you think about it, still works. Like 86 is, yeah, it's a 2-digit year, but it's also 86 years since 1900. So the definition still works. And what this allowed them to do was say, okay, when the year 2000 rolls around, the get year method is going to return not 00, but 100, because it's been 100 years since 1900. And it did end up breaking some programs because programs returned something like 19116, and actually this was kind of hilarious. I swear this is actually true. On January 1st, 2000, I logged on to various websites to see how they were handling the problem, and there were a lot of websites that said up in the corner it said January 1st, 19100. That's what it said for the date, because all they were doing was taking a 19 and tacking it on to the 2-digit, quote unquote, 2-digit year the get year was returning. And what you got was 19100, because actually it was 100 years since 1900. So get year is still returning the same thing. It's still returning the number of years since 1900. So they did have to fix it so that now, instead of just tacking on a 19 in front or tacking on a 20 in front, the right way to do it is to add 1900 to whatever the year returns. And now it returns the correct thing, no matter if you're talking about a date in the 1900s or a date in the 2000s or beyond. Okay, so this technique here should work pretty well for any date plus or minus 2 billion years or so. All right, centered around 1900. We got a question. Why BlueJ? Classmates and I were not fans of it a few years ago. Much prefer simple ID or editor explanation. The reason why I like BlueJ is this code pad that I'm using here. I can just try out stuff without making a class. Notice nowhere in here have I actually created a class and started writing anything in it. I'm just starting to just type stuff and see what happens. So this avoids having to make, like we'll find out later, what's called a main method and type some statements in there and compile it and run it. I can just try things out. And also this IDE is simple. There's just a compile button. To run it, you just type in something on the code pad here to get it going. The menus are very simple, and yet it does have a lot of powerful stuff that you find in professional IDEs, like the ability to run tests, the ability to use version management systems, and we'll do all that stuff actually in this course. So I like BlueJ, and certainly it shouldn't be something that you use forever. Eventually you should get advanced enough to work with something like Eclipse or IntelliJ or NetBeans, but when you're starting out, I think BlueJ is pretty good. It's very easy to get intimidated by the professional IDs with the myriad of buttons across there, of which you're only going to use 2 or 3 of them. And so why not just have a IDE, an integrated development environment that has just the buttons that you're actually going to use. So that's why I like BlueJ. Right, so I'm not at this point explaining what methods are and the code behind them. I'm just typing in stuff. So we're at the point in the semester where you haven't actually started writing a program. You're just getting used to typing in the syntax and invoking methods and seeing what the side effects of those are. All right, so thanks for the question. That was a good question. Okay, so now we have all the pieces to be able to construct the date in the format we actually want. So we need to add 1900 to the year. So let's bring up this thing that constructs it, and there's already the +1 in there. Now over here, we just need to add 1900 to what the year returns. Put it in parentheses, so that gets done first. And now we've got a date in the format that we expect. What if we do it European style, which I think is, if I'm not mistaken, the date first and then the month and then the year. So to do that, we do the date.getDate, add on the slash, and then it's actually this piece. We just need to rearrange the pieces, really. I'm just copying and pasting like that. There we go. So I think that's European style, and you can change the symbols that you have between them. Some locales use dashes instead of slashes. What we can't do with this is put the names of the months in there, like I was talking about a while ago, that we'd have to do some additional programming to get that to happen, but at least we can change the format. And then if you want to put the whole thing together, you have to use this along with the hours and minutes, and then just, it's going to be a big long expression, but you will get the month, the day, the year, the hour, and the minute all stuck together in a format that you expect. Okay, next one here. Use the various setter methods to change the fields of the date object to February 14th, 2016. So we can go the date dot set month. Oh, the month is already correct, so we don't have to do that. But if we wanted to change it to February, if today was not February, we would say set month. And then remember, February is month number 1. The date dot set date to the 14th. The date dot set year to 116. And then if we go the date dot toString, it should be the correct date. Let's try setting it to something in the past. Let's go the date dot set year to be 109, 2009. The date dot set month, 6 month. Set date 4. Oops, I want this one. Oops, Sorry, I'm scrolling around. There we go. I want this one. And that's July 4th, 2009. So remember, the year 2009 is year number 109. All right. And then the last thing is verify the date's been changed by using the toString method. So that's how you do that. So let's very quickly take a look at this file here. Okay, so this is the actual assignment. So you can see problem number 1 is very similar to problem number 1 on the sheet we just looked at. You're creating a variable called rooms, and you want to see what's the value of rooms if you don't yet assign a number to it. And then try to create a variable twice, and you should know the answer to that now. Create a variable called wind chill and set it to 5, and then write a statement that would add 10 to that number and store it back into the same variable. You should know how to do that. Multiply it by 2. So in our example, we were dividing by 2. So in this case, you're going to multiply by 2. And then write a statement to set the value of wind chill to -10. So you could either do that by doing some addition and subtraction, or you could just simply set it to -10. And then create a window, make it visible, set its title. That should look familiar. Make it visible, invisible, set its size. All right, so that's actually from the sheet we just did. And now make a new window called Win2. Show the window. Set the title to be your full name. Okay, so this is all stuff that I've reviewed over the last hour. Set the size of the window to be 100 wide, 200 high. Now use your mouse and manually move both windows. And then find out what's the height of the first window, what's the coordinates of the top left corner. I'm just reviewing all these questions. These are all questions now you should be able to answer based upon what I've gone over. Create a third window. Set the width and height of the third window to be exactly the same as the height of window 2. So you don't have to make the width the same, but the height needs to be the same. Set the location of window 3 to be directly below window 2, but separated by 20 pixels. So here's kind of a picture of what it should look like. So the left-hand side needs to be lined up. There's a gap of 20 pixels in between them, and you should be able to do that. Here's the date stuff. Oh, there's July 4th, 2009. I was picking that number out of my head, but now I know why I picked that number. There it is in the assignment. And then one of the challenge problems is to put the whole date together, along with the time. And then another challenge problem is to get those windows aligned so that they are touching at their corners. All right, so I think that's a review of what we learned this week. What we're learning how to do in the coming week is we're going to start writing our own program. So the problem we have right now is that as soon as we quit BlueJ and come back into it, all the stuff that we did on the code pad is going to poof, go away. This is just transient stuff. It evaluates the expressions of the statements and then it's done. It goes away. So we're going to start putting something up here, and I'll give you a little preview of that. So we're going to click on the button here that says new class, and we're going to give it a name. Let's call it, actually what we're going to do is we're going to take the existing JFrame class and we're going to make our own that is customized to the way we want it. So let's call this my win, whatever. Okay, and then when you open up a class inside of BlueJ, you'll find that there's already some stuff written there. And most of what you see in here looks like gobbledygook at this point. So what I want you to do is go select all and then press the delete or backspace key and just get rid of it. Forget about what's there. And we're just going to write from scratch. So we're going to go import javax.swing.jframe just because we're using JFrames and we want to save ourselves some typing. Then we're going to go class mywin extends JFrame. Okay, and that's it. That's it for now. So what we've done is we've created our own window we've taken the existing definition of JFrame and we've extended it and made it our own. And we've typed in 2 braces here, and in a moment here we're going to put something between the braces, but right now we just put an opening curly brace and a closing curly brace, and that's it. And we click on this button labeled compile. And down at the bottom, the compiler, the thing that translates our Java source code, what we just typed into the editor, is going to translate that into the ones and zeros that the computer actually understands. And so it comes up and it says class compiled, no syntax errors, which means we didn't do something like leave off a semicolon or a brace or something like that. So this says everything's good. So we need to bring up our main BlueJ window, and we see now that there's a new box here that represents the MyWin class that we just wrote. If we close this window and then double click on this one, it brings up that same, what's called the editor, the place where we type stuff in. So this is going to be a visual representation of everything we're typing into our programs. And when you want to edit one of the classes, one of the parts of your program, you just double click on it and this comes up. Okay, so at this point, we can go mywin w equals new mywin. Okay, and this is not really any different than what we've seen before, except that we're using mywin instead of JFrame, and we're creating a variable called w, and we can do stuff like make it visible. Oops, got to pass in true. We got a big error message from that said basically you need to pass in a Boolean and you didn't. Okay, there it is. W.set size 200, 300. Oh, there should not be 3000. So there's another example of an error message, you might say. It said it was expecting a parentheses and it didn't see one because I typed in a 0 instead of the parentheses. So there's the window, set title, my window, and then the title appears. All right. So what I've done here is I've created a program. I've created a class called MyWin. I'm just taking the existing definition of what a JFrame is and I'm making it my own. So this is now essentially, for all intents and purposes, it is a JFrame. It's just that it's called MyWin. So again, so I got a few more minutes. So another little preview of what's coming up is, notice how after we create a window, we need to do 3 things. We need to make it visible, we need to set its size, and we need to change the title. And so what we're going to do is we're going to put all of those statements, those 3 statements that we need to do, into our own method. And now that becomes something that MyWin knows how to do that JFrame doesn't know how to do by default. I mean, it knows how to set its size, but it doesn't know how to set it explicitly to 200 by 300. So this is what I mean by customizing a class, is we're taking the JFrame and we're making it our own. So the way you create a method that just executes 3 things is you go void, let's call it setup, 2 parentheses, open and closing, and then 2 sets of braces. And then inside here, we're going to put these instructions. Okay, w.set visible true, w.set size 200 by 300, and w.set, what was it? Title, my window. Okay, and if we click on compile, it's going to say can't find symbol variable w. So the compiler is saying you're referring to an object or a variable called w, but I don't see a declaration for that anywhere in here. And so what's going on here is we can't use w. Remember when I said a few weeks ago that whenever you invoke a method, you always give it the name of the object first, then a dot, then the name of the method. So you need to tell who do you want to address this instruction to, and then a dot, and then what's the action that you want to do. So we want to tell, in this case, what this statement is saying is tell w to make itself visible, but w doesn't exist. So actually we need to change this from w to this, the word this. And that's because what we're doing is we're creating a method called setup, but we don't want to tell some other window to change its size and make itself visible. We want to tell it to make itself visible and to change its size and to set its title. And so the word this is essentially a pronoun that means itself or self or me or something like that. So if you were the computer, you're basically talking to yourself. You're saying, me, make myself visible, and me, set my size to 200 by 300, and me, set my title to my window. But the word is not me, it's this. Okay, so this, the word this means I or me. So we're telling the window to make itself visible. Okay, so if we compile it, it says no syntax errors, and we're ready to try it out. So we go mywin w equals new mywin. And then to invoke this method called setup, we tell mywin to do setup. And remember, this is exactly as I've described. W is the name of the object, and setup is the action that we want it to do, semicolon, and then it does all three things just like that. Okay, so rather than us having to type in those three statements individually in the code pad, we've written them in the definition for the mywin class, and we told it whenever you call setup, do those three things really fast. And in fact, we can change the size. We can still tell window to set its title to something else. We can make it invisible by closing it. And then if we go setup, it'll run those three statements again, change it to my window, change its size to 200 by 300, make it visible, and it's just like we did it from brand new. All that other stuff we did is gone now. Okay, so that's a preview of what's coming up this week. Is we're now going to start actually writing programs. We're going to start putting statements, putting Java code into a file, and then being able to save that file so that later on, when we close BlueJ and open it up again, we'll get the same thing back, and we can repeat that over and over again, which is really the crux of programming, right? So writing down instructions and then being able to carry them out later on. All right, so I hope that you found this review and preview useful. If you are in my course, I will see you tomorrow, I think. Yeah. And if not, thanks for joining me. And I will see you again probably next week. Again, I do these once a week or so, where I either review stuff from my courses or I give a preview of something upcoming. I kind of rotate through my courses, so I'm not always doing the Java stuff every single week. But if you subscribe to my channel, you can get notifications about when I start these live events. Today I did 2 of them. This is my second one. And the previous one was doing some stuff with the Arduino, little tiny programmable computers. So if you want to see some interesting stuff, subscribe to my channel, get notifications, and I'll see you online next time. Bye-bye.